Good day, Liceo. I am Salle here from the Liceo Math Club. Today we'll be talking about factorization formulas. So this factorization formulas is very useful in your general maths and of course in your basic calculus when you reach the concept of limits, when you reach basic derivatives. Okay, so let's start with the common monomial factoring, which is of course the most basic of all factorization formulas. This common monomial factoring will tell you the formulas that nx plus minus ny is equal to n times the quantity of x plus minus y. Okay, that is, since you can see that n is a common factor in both these terms, the idea in common monomial factoring, commonly known as CMF, is that we're going to get the common factors and then put them outside, okay, in such a way that they will be in this form, and then inside the x and y will be capsulized in the group A. In such a way that we're going to picture this out. If we're going to distribute the n, it will be going back in this form here. Okay, to see some examples, say you have 4x plus 2. As simple as that. So we can see that 4x plus 2, there's a common factor of 2 here. Okay? In such a way that it will be, if we're going to prime factorize everything, this will be like 2 times x plus 2. Right? So you can see that there's a common factor of 2 here and 2 here, okay, in this form. So if we're going to get the common monomial factor, this will look like 2, that's your n. Open parenthesis, 2x plus, since we got that 2 here, recall that in every term, by the identity property of multiplication, there will always be a 1 in this form. Okay? So of course, this will be times 1 also. Okay? So if we're going to get the 2 out, what will be left over here is the 1. Okay? So therefore, 4x plus 2 will be equal to 2, that's your n. Imagine your x here as your 2x plus your y is 1. To give you one more example, say we have EG number 2. Okay, say we have 7x squared plus 3x. Okay, so imagine here we're going to get the common factor from each of these terms. Okay, so to make things very clear, let's put it in this form. So this will be equal to prime factorize. Since 7 is a prime number, so just copy 7 there. Imagine x squared is like multiplying x by itself. So we can just picture this out like times x times x. Okay, 7 times x times x. So plus, we have 3x, so 3 times x. So notice we have a common factor of x over here. Okay, that will be our n. As our n. So what we'll have is to take that x out, x, times the quantity of whatever will be left in this first term will be 7x. Okay, and what is left on the other term is 3. So this is our factoring common monomial factoring. Okay, so it's your turn. We have here some exercises, only 3 items. So we have the direction here, factor these using CMF. So we have probably, we may pause the video for okay, so after you pause the video, I believe you have some answers there, your piece of papers. So let's try to verify the values, or let's check. Okay, starting here from number 1, we have 4y minus 12. So we can see that both of these numbers, this coefficient here and this constant here, are both multiples of 4. Okay, so we can get that 4 out. Imagine that 4 as your n. So this will be equal to, since we're going to get the 4 will be here. Okay. So imagine 4y. We're going to get the 4 out. Okay. So what will happen here? So we will just get the 4. There will be a 1 left. Again, since 4 is 4 times 1. Imagine that as 4 times 1. So there will be a 1 left. 1 multiplied by y will simply be y. Okay. And copy the sign. Minus. This 12 is also a multiple of 4. So thinking 12 as a multiple of 4 in this perspective, imagine that 12 is 4 times 3. So if we're going to get 4 out, we will be left with simply 3. So this is your answer number 1. Number 2, so we have 6z squared plus 9z. So this one is quite challenging, you know. So we can see that the coefficients are both multiples of 3. That is 3, 6, 9. You can see that this is the second multiple, this is the third multiple. And also their variables are the same, but not to the same degree. Okay? So imagine this as the 6 to be a multiple of 3. So if we're going to look at it in that perspective, 6 will be 3 times 2. Okay? And this z squared, multiplying it by itself, this will look like z times z. Okay? So this is the prime factorization of our first term here. So put the plus sign. Okay, 9y, look at it in the perspective of as a multiple of 3. So 9 will be again 3 times 3. Okay? And this z will be over here. Okay, so we're going to look at the common factor, which is our n. So what is our n here? We have 3 times 2 times 3 times z. We have here 3 times 3 times z. So we can easily see that we have a common number, which is 3 here. And we have a common constant, or rather a common variable, okay, which is the z. So getting your n as your 3z, we can work things out and factor this using c and f. So imagine your n, the one here outside the parenthesis, to be 3z. Okay, if that's the case, open parenthesis, what is left of the first term? So it can be clearly seen that we have 2 times z. So we have 2z here in the first term. After this, since we took the 3z in the second term, what is left is just 3. So this is your answer number 2. 3z times the quantity of 2z plus 3. This is your number. Okay, hopefully you've got the answers correct. So for number 3, okay, so this is a more challenging one. So first look at the coefficients. They're both multiples of 2. Let's put it in our minds. And we have 2 variables. We have an m and an n. M and an n. So to picture this out clearly, let's do the number 3, the same thing we did with number 2. So we're going to factor this completely. Okay? So number 3, the first term here will be 2 times m times n, since we know it's m squared, times n. We have a single m here. Minus, we have 4. Let's put it in the perspective of as a factor of 2. So it will be 2 times 2. Okay, 2 times 2. And then m is only a single variable, but n here is squared. So imagine that as n times n. Okay, so we're just going to look at the common factors here, the common numbers, common variables, and such. Look at the 2. So we have a common 2. Okay, that's surely one of your n. We have a common m. We have a common m here. And lastly, here we have 2 n's, but we only need 1. We only have 1 n here, so 1 n here. Okay, so these are the common factors in both of the terms. That is your n, common factor n. So what we're going to do with these terms in the box, we're going to put that outside the parenthesis. So what will happen is 2m n. Okay? And what will be left inside the parenthesis will be the things left in here. So in the first term, what is left here? Clearly, it's just an m. Copy the sign, minus, copy the operation rather. What is left here in the second term? So that is clearly 2 times n. Okay. So this is your answer in number 3. Okay. 2mn times quantity of m minus 2. Hopefully you got a score of 2 or 3 here. And yeah, that's it. So the second factorization formula you will be learning this day is the difference of 2 squares. That is, it states here in the formula, x squared minus y squared is equal to the quantity of x plus y times the quantity of x minus y. We have a requirement requirements that the first term should be a perfect square. The second term should also be a perfect square, and the operation between them should be a minus sign. Okay? If this happens, therefore it suits the requirements of the difference of 2 squares, commonly known as the DOPS in some books. So if you have these perfect squares and a minus in between, you can do it like this. For example, we have, say, z squared minus 9. Okay, so we're going to look at first if the 2 terms are perfect squares. So you can see that z squared here Well, it's a perfect square, obviously, because it's a square. And 9 is also a perfect square. That is, it's a square root. The square root of 9 is 3. So, and then there's a minus in between. So if this happens, it suits the requirement. Therefore, we can apply this formula above. So if we're going to do that, this will become, so what's the square root of z squared? That's z. Okay, what's the square root of 9? That is 3. Then we can do it like this twice and just fill in the plus minus sign. So you can do plus here and minus here. Or you could do the reverse. Anyway, they're common. Okay, more examples. We'll have, say, you have 4x squared minus, say, 16y squared. Okay, so you must make sure that both the terms, including the coefficients and the variables, are perfect squares themselves. So you can see 4, it's a perfect square of 2, which is the square root of 2. Square root of 4 is 2, that's it. Okay, square root of 16 is also 4, so they're both perfect squares, including the variables, so therefore we could apply the formula above. That is, open parenthesis, the square root of 4x squared is going to give us 2x, okay, and the square root of 16y squared is 4y. So we do that in both groups for y, both groupings. So we can put the plus sign and minus sign here, and that ends up our difference of two. So it's your time here to answer the exercises. So the direction is factor using the difference of two squares. So we have here some examples. You may pause the video if you want. I believe you have the answers now for you pause the video. So let's answer 1, 2, 3. Okay, so again, let's look at number 1 here. This is a squared minus b squared. Both are perfect squares. The operation is subtraction. Therefore, that suits the requirements for the DOTS. So let's have this. Okay, what's the square root of a squared? That's a. Okay, what's the square root of b squared? That's b. Do this in two groupings, and you'll have a plus or minus sign. Okay, we'll have this answer. Therefore, you got it. Okay, one more thing. Some of the books will not present it in XY variables. You may see some books that it presents you the a squared minus b squared formula. So in some books, it will display you this formula. But anyways, they're just variables. Okay, for number 2, look at the first term. It's a perfect square. 25 is a perfect square of 5. We have m squared. It's a perfect square also. We have n squared on the other term. That's a perfect square. So how can we factor them? So square root of 25 is 5. Square root of m squared is just m. Okay, so the square root of n squared is just n. Okay, we'll do this in two groupings, and we'll just supply the operations plus minus. Okay, so this is your answer in number 2. Okay, hopefully you got it here, number 2 here. And number 3, well, we can see some improvement here. We have j to the 4th minus I to the 4th. Okay, so what happens if we're going to get the square root of j to the 4th? So simply, we're just going to divide this 4 by 2, okay, to get the perfect square. Okay, you can just imagine that j squared times j squared by the power of product in your exponents. That will, the bases are the same, so you can just add the exponents. That is j to the 4th. So therefore, if we're going to get the square root of j to the 4th, that will give you j squared. Okay, the absolute positive of j to the 4th is j squared. So same as I to the 4th, that is I squared. That is their absolute square root, absolute positive square root. So what we'll have is j to the, or j squared here, and then we have I squared. Okay, so we'll do this on the other term. Squared, and then we'll just fill in the plus minus. And this is your answer in number 3. Okay, hopefully you got it. A score of 2 or more here. Okay, and then we'll proceed to the next factorization formula. Okay, so the third factorization formula that we'll know is the perfect square trinomial. So this is the formula. The difference of the factorization before is that the square is outside the parentheses. Okay, so imagine here the second formula, we have quantity x minus y quantity squared. So that's the OPS if we're going to put the x squared minus y squared. So, but if the square is outside, then this one is capsulized with the grouping, so we're going to use this formula here. So just follow the formula, I won't stress that out. So how do we do this? Actually, there's a shortcut of doing this. For example, if we're not going to follow the formula, okay, this will be like this. Say we have a plus 2 quantity squared. So what's the shortcut? We have 3 terms. You can imagine that 3 terms. So we have blank, blank, blank. Okay. First up, a times a. Imagine a times a. A times a. That's a squared. Put a squared here. Okay. Second term, a times 2 times 2. Imagine this square is a 2. So a times 2, that is a times 2 times 2. That will give you 4a. And then it's positive, therefore this will become positive 4a. Okay. And for the third term, 2 times 2. 2 times 2 is 4. Positive 4, therefore that's plus 4. Okay? Without even memorizing the formula, you can get that. Okay? Another example, say we have, let me write here. Okay. Say we have b minus 1 squared. B minus 1 squared, again, we're going to use this pattern. B times b is b squared. That's your first term. Imagine the 3 terms again. Middle term, b times negative 1, because 1 is minus, so that's negative 1 times 2. So if I'm going to write the middle term, b times negative 1 times 2, so clearly this will become negative b. Negative 2b, negative 2b. So since it's negative, follow the sign, which is the operation, negative 2b. And the last term will be negative 1 times negative 1. So since both of them are negative, negative 1 times negative 1, this will become positive 1. That is plus 1. Okay, so as you can see, we didn't stress out the formulas. You can just do them intuitively. Okay? Okay, so you can do this as your exercises, factor using the perfect square triangle. Now you may pause the video if you want. I hope you had the answer already. You have the answer already. So let's answer this. Again, don't stress out the formula, just look at the patterns. So I'm going to input it like this. So we have 3 groups of terms. For the first term, z times c. Okay, so z times c is z squared. Okay. For the middle term, we have z times negative 3 times positive 2. So z times negative 3 is going to give us negative 3z multiplied by 2. So that's negative 6z. Okay, and for the last term, negative 3 times negative 3, that gives us positive 9. Okay, negative 3 times negative 3. Okay, so this is your answer for number 1. Okay, for number 2, we have j plus 4 quantity squared. So again, just look at the pattern that I'm going to use. J times j is going to give us j squared. Okay, for the middle term, j times 4 times 2. J times 4 is 4j times 2, that's 8j. And there's no minus sign there, so that's plus 8j. Okay, and then for the last term, 4 times 4, that's 4 squared, that is 16. Okay, so your answer number 2 should be this. Okay, and lastly, so we have here quantity e minus 5, quantity squared. E is a variable, okay, not a constant. So what we'll have here is, again, imagine the 3 terms that I talked about. So for the first term, we have e times e. So that's e squared. Okay, middle term, e times negative 5 times positive 2. So imagine e times negative 5 is negative 5e multiplied by 2. That's negative 10e. So minus 10e. Okay, and for the last term, negative 5 times negative 5, it's both negative, so that's positive 25. That ends up the perfect square trinomial exercises. Hope you got 2 or 3. Thank you. So this ends our video for today. Don't forget to hit the ring button over here. I think it's right here over here. So that's the subscribe button for you to be notified for our latest videos and uploads. Don't forget to hit the like button, and then if you want any suggestion for our next video, we would really appreciate that. Just put there down in the comments. Scroll down and then hit the comments and then there. So thank you so much. I'll see you next time.